Hello everyone, welcome back to the workshop. Today we're jumping back into the CNC and I am going to show you how I make these bottle openers from scrap cut off pieces of wood. This is a simple profile and pocketing cut on the CNC, and then just these simple steel bottle opener inserts, and then throw them on the laser, put some sort of simple engraving on it. So I'm going to walk you through this on Vectric. We'll get it on the CNC, we'll throw an engraving on here, finish it all off. And if that sounds interesting to you, want to see how I do it, stay tuned. We're going to jump right into it. I have my scrap piece of oak. This is actually a panel, a glue up panel that I forget where I got it from, but perfect case use for this. It's kind of in my pile. We all keep these kind of cutoffs around. And we're going to see if we can use this up and make a few bottle openers. So first thing we want to do is measure the size. And so I'm just with the tape measure here, we're looking at 7 1/4 wide and about 8 inches tall. And then good to have a calipers when doing this because we really want to get an exacting depth. So I'm going to just double check to see what our depth is coming in at. And we're looking at about 0.755. So we want to make sure we set that to that thickness, because if we went just 0.75, we would be leaving 5/100ths there, and probably not the biggest deal. We could probably clean that up, but we want to make sure we get through this whole thing. So the other thing I'm going to be concerned about is with these bottle openers, I'm going to want them to going the long way with the grain just to give it the most strength. So we want to remember that our 8-inch is the height. So let's jump into Vectric. We'll get this set up. All right, we're over here in Vectric, and the first thing we are going to want to do is set our job dimensions. So we're going to come up to this icon over here, and job type is single-sided. So here's where we set up our job size. So our width, we said, was 7.25. Our height was 8, and our thickness was actually 0.755. We're going to zero off the material surface in this operation, and our origin is going to be in the lower left. So those are the critical ones that we need here. Let's go ahead and hit OK. All right, so now that we have our job origins in here, let's go ahead and import our vectors. I already have this created, so we're going to go ahead and import vectors and bottle opener curved. So now we have one copy of it down here. And you can kind of see we've got the outline profile. We have the through cut for kind of our finger grab or the hook hanging spot. You can put a leather strap through there, whatever. But over here, it's more important. We have that round cutout. That's going to be a shallow pocket, about 0.8 inches or 0.08 inches for the metal plate. And then the pocket that's going to go behind the metal plate that allows you to get the bottle opener in there. So what we can do is we can actually replicate this. So I'm going to go ahead and select them all. And you could use the array copy tool here. So we can set that up. And I think we can fit 3 on here at a 1/2 inch gap in the y-axis. There's one column. We hit copy. That will go ahead and make multiples. And then what you can do is use your transform tool and reposition it a little bit. You do want to be mindful that you leave enough gap between them. As you're coming closer, your paths may overlap. As long as you have enough holding material down or tabs working for you here, that'll be okay. But you do want to be mindful that you're not going to run into any of your hold downs and that you're not going to break through on any of the edges. That's going to cause things to slip. So with them spaced out like this, we may want to just take advantage of the shape here. And we're going to go ahead and select this one. And then I'm going to rotate it around like so. That'll just give us a little extra clearance on all these. And as a matter of fact, I'm just going to nudge it over a little bit more. So use your discretion. Just make sure that you have enough clearance around both of them to be able to get it where you need it to. So once we have our layout fine, since I'm importing all the vectors, we don't really need to adjust them any. We are going to come up to our tool paths. I'm just going to pin it here so that it stays. And we want to set up our order of operations for this. Now we're going to use a 1/4 inch bit for all of it so we can just move through it without bit changes and such. So the first thing we're going to do is we're going to pocket out this shallow spot for the circular steel part. So I'm going to click on that one. I'm going to hold shift, select this circle and this final one. And we want to come up here and do a pocket tool path. So we want to start at 0, but we're only going to go down 0.08. We already have decimal in there, so 0.08 inches. And we're going to go with our end mill. I'm going to be using my Genmitsu 6050 with the new Bauer router. I'm still kind of dialing our speeds and feeds. So what I have this set up at is we're going to go with a 0.125 pass depth. We are going to go with a feed rate of 40 inches a minute and a plunge rate of 25. So we'll do that okay. And we are going to use a conventional offset path. And at this shallow, I'm not going to worry about ramping the plunge moves. And if we wanted to, we could rename this pocket, or I'm just going to call it pocket 1. So we're going to calculate that. It's going to bring us into this little preview. It will show us what it's going to do. If we want, we can click the preview and it'll show us we're going to put 3 little pockets in there. So that is good. We're going to jump back to our 2D view. Next, we want to move on to our actual opener pocket. So we're going to, once again, select, hold shift, and click on each of the vectors. We're going to come back to our pocket tool, and now we're going to start at a depth of 0.08, and we are going to go down to a depth of, I think, 0.45. So we'll put that in there. Again, offset conventional, but we want to double check. Here again, we're just doing a pass depth of 125, so about 1/8 of an inch each pass. And step over is fine. This can be, this doesn't need to be too fine of a pocket. It's a small area and you're not really going to see it. If you're doing something bigger like a bowl, you might want to lower this, but this will be fine. It's less than 50%. Again, feed rate 40 inches per minute and plunge rate of 25. Here we may want to ramp our plunge moves. Again, I'm not going to worry about it too much in this pocket. We'll worry about that more on our profile. Then we go ahead and go calculate on that. Again, we can preview this, and there you see how it is going to pocket out those areas as well. So there is our first set done. Next thing I want to do is move to this inside path. We're going to, again, hold shift, click on each one, and we're going to come up here, and this time we're going to be doing a profile path. So we're going to go start at 0.0 inches, so that's the top. We're going to go down 0.755, and we're actually going to be doing an inside, so that will determine which direction it needs to go. I'm going to switch this to conventional pass. You can do a separate last pass. What that does is it'll do the first ones with a tolerance that you set up, and then on the last pass, it'll bump it in just a hair to do a full depth cut, and that helps eliminate any lines that would appear in there. I'm not going to worry about that in this one. On that inner pocket, we're actually going to be doing a round over there, and so we'll get rid of most of those. So we're going to leave that off. I'm going to be using double-sided tape, so I'm not going to worry about tabs. If you're not doing that, you may want to put tabs in just so it doesn't get that doesn't work loose and cause you problems with your bit. And I'm going to add ramps to this. I'm going to go 0.25 just to make it a little bit smoother as it's digging into there. And we will call that profile number 1. We'll calculate that out. There's your preview of it, and you see that it's cutting all the way through and just leaving this little circle in there. We could have pocketed the whole thing out, and then it wouldn't leave this. That just takes more time, but it would be a little bit safer. It means that this gets moved out in chips rather than just a little peg left in the middle there. Again, depends on your holding pattern. If that becomes a problem, you may want to add that extra time to just pocket that out all the way down. But like I say, it will add time to your cut job. So our last job operation is going to be our outside profile. So once again, hold shift, select your vectors, and we are going to come up to, again, the profile, starting at 0, going down to 755, using the same tool path, but now we're going to move this back to outside. And here I am going to do a separate last pass. It's going to be on the outside. It's going to be visible. I am going to make this basically 0.05. Let's go half of that. So 5 thousandths. You just barely touching that last inside bit just to cut a nice smooth bit all the way through that. Again, I'm using double-sided tape, so I'm not going to worry about tabs on this. Do want to add ramps to it. Again, 1/4 inch is fine. It just means that that bit isn't digging down straight in. It's ramping it in a little bit. So do that. We'll calculate that out. Once again, preview it, and then you see we have our profiles. So now we have all of these set up. They're looking good. So we can go ahead and select all our tool paths. Let's go ahead and save this to a toolpath. And we want to save the visible toolpaths to one file. And I have my machine set up, the Prover XL6050. We're using millimeters because that's what the processor is looking for. And we're going to go ahead and save this toolpath.
All right, so real quickly, I'm just going to show you, I'm going to be using a 1/4 inch downcut bit. Now this is one from Cadence Manufacturing. It's their 1/4 inch style of their downtown Jenny. And these are some awesome bits I've been using for a while on my other CNC machines as well. And Cody, who is the owner and operator of Cadence Manufacturing, has been creating these bits kind of for CNC hobbyists for quite a while, and has recently really brought a lot of the manufacturing into his own shop down in Arizona. So I will link to these down below. There's not affiliate links at all. I just love these bits, and I've been using them and love the way he supports the community. So I'm gonna get this, I've got this one chucked up in the Bower because I have more than one. And so we already got that one in there. We're gonna be running that, and I will get the material fastened down. Now, I often use the CA and painter's tape method, where you put some painter's tape down on the surface, you put some painter's tape down on the bottom part of your material, use a little CA glue, activator, push them together. That works as a good double-sided tape, and it tends to be a little less gummy than using others. I am going to actually be using some just straight up double-sided tape this time to adhere this down. That should give us a good hold across the whole thing. The only issue with this is that you can sometimes pull up a little bit of that gummy adhesive, and that gets into the flutes of your bits. It may or may not cause a problem for you. There's all sorts of different ways to hold your material to your CNC machine. You can use some screws into the material, into your wasteboard. You can use clamps of various sizes. But for this, it's fairly simple to use the double-sided tape, and allows me to get away with not using tabs. So I'm gonna get this set up, and then we'll run the job. All right, so the CNC finished cutting out my blanks, and that went really well. The 3 of them took about 13 minutes, so really not too bad, a little over 4 minutes a piece to cut these out of a cutoff. And so what I'm gonna do next is I'm gonna put this through the router. I'm gonna give it a nice little rounded over edge, and then I'm gonna go ahead and sand these down because you want them nice and smooth for the hands. So, you know, if you've got a handheld trim router, you can do that. These are a little small, so just be careful. Make sure you're comfortable with doing that. Otherwise, you can probably sand in, kind of just soften the edges. And then if you have a stationary sander, but even a random orbit, or as always, just hand sanding works as well. Just want to try to soften the edges, get any tooling marks that might happen to be in there out, and give it a nice feel to the hand. So let's do all that, and then we'll get these ready for engraving.
All right, so we have our blanks done. They're sanded. they're ready to be engraved. Now I'm going to be using the xTool F1 as this is a portable unit, and you may want to get these prepared. You may even want to finish them and engrave them on site. However, you could use CO2, a diode, any laser at this point that can mark on wood. So we're going to jump into xTool Creative Space and we'll set up some engravings. So let's do that now. All right, so we're in xTool Creative Space, and I've brought in my logo to play around with the first one. And with this one, I've ran a material test on similar material, and I've come up with approximately 200 millimeters per second, 75% power, 100 lines per centimeter. So all I really need to do at this point is get our image set up onto the material. So one of the nice things about the xTool F1 is its ability to frame and actually give you an outline of the object. So I'm going to go over to our three dots here, and we're going to go to outline instead of rectangle, and I'm going to click on the framing option. And as you can see over here, it is giving us a nice outline of our engraving. So we can make adjustments from here. And if you like it at that size, you could go with it. You might want to just double check that it is in the right position, or if we feel we need to make it a little bit smaller or bigger, we could. But I'm going to roll with it at that size. I'm just wanting to make sure that we have kind of equal distance on each side. I think I'm going to bump it over just a little bit. But this live preview is really nice. So let me kind of try to zoom in a little bit there, and you can just kind of see the item fairly well. So once we're happy with that, we can stop framing, and we can slide our enclosure down to protect ourselves. And we'll just double check our settings here. We've got 275. We're going to go ahead and hit process. It will start the engraving, and we'll check it when we're complete. All right, it took 1 minute to complete. We can open this up and take a quick glance at it before we move it. And it's pretty decent, but because of the grain, we have a little darker spot than the others. So I'm actually going to go ahead and have this process again, just to see if we can kind of even that out and darken it up just a little bit. So nice thing we can do here is we can just hit process again and run right over the same image. All right, so we do have that one done, came out okay. Due to the nature of wood and oak like this, we do have kind of that little darker spot, but I think once we oil this, it will kind of even out. So definitely something you're going to want to play around with your designs and the type of wood you use as far as what's going to work well. But let's go ahead and try to design up a couple more. All right, let's go ahead and we're going to import another one, and I should have a bigger SVG. We're going to scale it down. So let's bring this down to size. First thing I want to do is actually combine and subtract overlap. That's going to create them as one. Switch this to engrave. So now we have just a couple of beer mugs sitting there, and we're going to go ahead and adjust our power and speed settings on this. So we're going to take it all the way up to 100. I'm going to drop this down to, I think, 150. We'll give it a little bit better. And let's go ahead and get it framed up.
All right, so these metal blanks are available. I'll leave a link down below on Amazon. And the nice thing is with this file, that'll fit right in. It'll sit nice and flush. And all you need to do is drill some pilot holes. They do come with small little screws that will countersink right into these. But I like to drill pilot holes. I have a nice center finding bit here. So all we need to do is drill a couple holes. So they're there. And then we'll be able to put these in with a Phillips head. So we'll do that, but before, so I'm gonna get those all drilled out. I like to do that before I oil them. We'll get them oiled, let them cure for just a little bit, and finish them off. So I hope this video was informative to you and gave you a better idea of things you can do with CNC machine, scrap wood, and pair it up with your laser engraver. Definitely something that if you are in the market of customizing items, being able to make your own blanks using the CNC machine and then customize them with the laser is definitely attractive and can help boost your profits or just enjoy more shop time for you. I'll have a link down below to all the items used in this, from the metal blanks for these to the CNC machine and the lasers and such. A lot of those links will be affiliate links. They do provide a little bit of kickback to me at no extra cost to you. So I appreciate you using them. They do help to support this channel, but as always, no pressure, just happy to share the project and hopefully inspire you. If you have any questions or comments for me about this or anything else you've seen in my workshop, go ahead and leave that comment down below. If you like this video, hit that thumbs up. And if you're new here, like what you saw, consider subscribing. I do project videos, instructional videos, and some product reviews on this channel, and would appreciate seeing you back again. So once again, I thank you for watching this video. I hope you enjoyed it, but most importantly, I hope you can get out into your workshop and make something too. We'll catch you next time.